impedance parameter, we express the input port voltage and output voltage as a
I1,
function
I2.
I1, I2, function of input port current and output port current. This is all the network. The input port, 1 dash, 2 dash output port. This current is entering. This current is also entering. This is the input port voltage V1 and output port voltage V2. So we express the input port voltage and output port voltage as a function of I1, I2. And V1 is equal to Z11 I1 plus Z12 I2. And V2 is equal to Z21 I1 plus Z22 I2. So basically, this one is the Z parameter. Our objective to find out the Z parameter. What is Z11? Z11 is equal to V1 by I1 when I2 is equal to 0. When I2 will be 0, that means output port is open circuited. No current will flow in the output port. If the output port is open circuited, no current will flow. That means I2 will be 0. So when I2 is equal to 0, we can get the value of Z11, which is equal to V1 by I1. It is called input driving point impedance with the output port open circuited. Similarly, Z21 is equal to V2 by I1. Z21 is equal to V2 by I1 when I2 is equal to 0. This is called forward transfer impedance. Now, Z12 is equal to this is equal to V1 by I2 when I1 is equal to 0. That is input port open circuited. Similarly, Z22 is equal to V2 by I2 when I1 is equal to 0. That is the input port open circuited. So ultimately, all the Z parameters can be, we can find the all Z parameters when the either input port is open circuited or output port is open circuited. That's why the Z parameter is called open circuit impedance parameter. Now, next condition is we have to find out the condition of reciprocity and symmetry. One theorem is there, reciprocity theorems. Reciprocity theorem. What it said? When a network is said to be reciprocal if the ratio of the response transform to the excitation transform. Basically, when the input port voltage, we are connecting a voltage source Vs. So V1 is equal to Vs and one current is entering. And output port, so shorted whatever. In reciprocity, according to reciprocity theorems, the ratio of the response. Remember that if voltage is the cause, if voltage is cause, the response is obviously current. If current is cause, If current is caused, then response is equal to voltage. So our objective, we have to find out the condition of reciprocity and symmetry. Condition of reciprocity and symmetry. For Z parameter. What we have seen, the Z parameters are Z11, Z12, Z21 and Z22. These are the Z parameters?
Yes, sir.
Now I'm drawing one figure. So, okay, already I have drawn it. So this one is the network N. This one is the figure 1. And the output port, output current is I2 is equal to this one. Now, if I am shorting the terminal, this 2 dash, right? I'm shorting the terminal, then I2 dash current is, now if I short it, the current is I2 dash. Our network is said to be reciprocal if the ratio of the response sorry, ratio of the response transform to the excitation transform is invariant. VARIANT. Invariant, never changing. Invariant to the invariant to an interchange of the position of the excitation and response in the network. What does it mean? A network is said to be reciprocal if the ratio of the response transform to the excitation transform is invariant to an interchange of the position of excitation and response. That means, as I told you, if Vs is the cause, the response is current. Now, Vs is input voltage So we are applying a voltage source at 1, 1 dash, 1, 1 dash, and we are getting response at 2, 2 dash. If I change the position of the Vs from port 1, 1 dash to port 2, 2 dash, and that time we will short the input port, we will get in some current, say I1 dash. So the ratio of the excitation response to excitation transform is invariant if we change the position, interchange the position of the source. So remember that you have to draw this figure properly. Better I will draw the figure again, otherwise here we have to derive. One dash, two dash, and we are applying a voltage source in 1 dash. This one is the Vs. I1 current is entering. This is I2, and we are shorting a 2 terminal. So this is I2 dash, and this current is flowing in these directions. So short circuit port 2 as output port and apply voltage Vs in port 1. So now V1 is equal to Vs, and as output port is shorted, so the V2 will be 0 and I2 is equal to minus I2 dash. It's clear? So I2 is equal to minus I2 dash. This is I2. So I2 is equal to minus I2 dash. So I'm putting these values in the equation, say V1 is equal to Z11 I1 plus Z12 I2. So V1 is equal to Vs and Z11 I1 is there, I2 dash is equal to minus I2 dash. So this is equal to minus Z12 I2 dash. This is equation 1. And another equation is V2 is equal to Z21 I1 plus Z22 I2. So here V2 is equal to 0. And this is Z21 I1 plus, this is not plus, because I2 is equal to now minus I2 dash. So this will be Z22 I2 dash. This is equation 2. So I2 dash is equal to now how to find out the I2 dash? So again in the form of matrix, what I am getting V1 so this is V1 is equal to Vs, so this is Vs, V2 is equal to 0 is equal to Z11, Z12, Z21, Z22, and this one is I1 and minus I2 dash. So from this, I need the value of I2 dash. So I2 dash is equal to Vs into Z21 using the Cramer's rule. Vs into Z21 divided by Z11 Z22 minus Z21 Z12. Any doubt?
No, ma'am.
Okay. Now,
No, ma'am.
okay. So now another one, I'm drawing the circuit. I'm the interchanging the position of the voltage source. Now we are applying a voltage source in port 2 dash. So this is my Vs and this port is open circuited.
ম্যাম উপরে Z11 টা বোঝা যাচ্ছে না একটু
Z11
মানে VS Z21 by Z11 Z22 ওই Z11 টা বোঝা যাচ্ছে না
মানে I2 dash is equal to Vs Z21 এটা
হ্যাঁ ম্যাম
বেসিক্যালি দেখো ইন এনি ম্যাট্রিক্স যখন আমরা V1 V2 বার করব এখানে যদি তোমার Z11 Z12 হয় Z21 হয় Z22 হয় এটা I1 I2 যদি হয় আমার এখানে আননোন হচ্ছে I1 I2 তখন কি হয় I1 is equal to del 1 by del. What is del? Del is equal to Z11 Z11 Z22 but just cross multiplications. এটা তো করেছো তোমরা ম্যাথসে মাইনাস
কেন
Z
ম্যাম সেটা বুঝতে পেরেছি ম্যাম আপনি ওখানে Z11 টা ঠিক করে বোঝা যাচ্ছে না আমি সেটা বলতে চাইছি
এই জায়গাটা এটা
হ্যাঁ 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 আমি
লেখাটা পরিষ্কার নয়
হ্যাঁ ম্যাম সেটাই বলতে চাইছি
ও আচ্ছা 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 ঠিক আছে আমি আসলে একটা ক্রিটিক্যাল জায়গায় রয়েছি আমার টেবিল চেঞ্জ হয়ে গেছে সো আমার যেটাতে আমি লিখছি সেটা আমার থেকে অনেক দূরে আমি একটু মানে আমার টোটাল সেট আপটা চেঞ্জ হয়ে গেল তো যার জন্য আমি একটু ঘেটে গেছি
ও আচ্ছা
ঠিক আছে এটা Z11 হ্যাঁ তো এখানে আমরা আমরা এই ফিগারটাতে এটা ফিগার 2 তে at that time 1 dash is shorted so current is now previously this is I1 and it will be now I1 dash so I1 is equal to minus I1 dash and this is your I2 this is network now what we have done short circuit port 1 and apply voltage source Vs at port 2 so short circuit port 1 and apply voltage source Vs at port 2. Now we are applying putting all the values. Now V2 is equal to Vs, V1 is equal to 0. So I1 is equal to minus I1 dash, and V1 is equal to 0. Oh, I have written it. So the equation will be 0 is equal to Z11 I1. So it will be minus Z11 I1 dash plus Z12 I2, and V2 is equal to Vs now. V2 is equal to minus Z21 I1 dash plus Z22 I2. So again, I can find out the value of I1 is equal to I1 dash is equal to Vs into Z12, Vs into Z12, this del 1 by del 2 now. So Z11, Z22 minus Z12, Z21. So comparing,
हम प्लस होगा ना
कौन सा
हम
क्लास
जेड
होगा?
वो मतलब Z11 Z22 प्लस Z12 Z21 क्योंकि वहाँ पे माइनस
Always
Z21 आ रहा है.
matrix is always this one is cross multiplication. The Z11 into Z22 minus Z12 Z21.
माइनस है.
मैम Z21 के पहले तो माइनस है ना, तो माइनस माइनस तो प्लस हो जाएगा ना.
वो करके देखो ना, देखो पहले देखो ये I2 dash ना, this is I1 dash, this is I1 dash. We are finding the value of I1 dash from here, and this is I2 dash. वही होगा जो मैंने लिखा वही होगा. जस्ट एक बार प्रैक्टिस कर लो, वही होगा. Okay. Now we are comparing I2 dash and I1 dash. So initially the cause was voltage and I2 dash is the response. And second case, we have applied Vs in port 2 and I1 dash is the response. Comparing I1, I2 dash and I1 dash, the condition of reciprocity theorems becomes how both will be same according to reciprocity theorem. What was the theorem? I have written it. Ratio of the response to transform to the excitation transform. The response is I2 dash. First is I2 dash response, cause was Vs, right? And second case,
I1 dash
I1 dash by
plus
Vs.
by Vs.
So if this one is the same value, that means I2 dash is equal to I1 dash.
Yes, ma'am.
So comparing I2 dash and I1 dash, we get the condition of reciprocity theorem. We can get Z12. See, in both cases, Z1 in one is Z12, another one is Z21. देखो, here it is Z12. Now, in the previous case, Z21. So, we can get Z21, Z12 is equal to Z21. So this is the condition of reciprocity This is the condition of reciprocity. That means when the network is reciprocal, Z12 is equal to Z21. Similarly, the condition of symmetry, now we will derive the condition of symmetry. When the network is symmetrical network. That time we are applying voltage V1 and port 2 is open circuited. So we are applying voltage V1 1 dash. So we are applying Vs at port 1 and output port is open circuited. Open circuit is I2 dash, I2 will be 0. This is I1. This is network N. For condition of symmetry, apply voltage Vs at port 1 and port 2 is open circuited. And find Vs by I1. As it is open circuited, output port is open circuited. So therefore, I2 will be 0. So in the equation, V1 is equal to Z11 I1 plus Z12 I2. V2 is equal to Z21 I1 plus Z22 I2. So I2 will be 0. So V1 is equal to Vs. So V1 is equal to Vs and this is equal to Z11 I1. So Vs by I1 is equal to Z11. Now again we just replace the voltage source at port 1 to 1 2 and now open circuit the port 1. So now what you will do, now you apply the voltage source, now V2 will be Vs. Now input port is open circuited. As input port voltage, input is open circuited. So now V2 is equal to my Vs and so I1 is equal to 0. So the V2 is equal to Vs. I1 is equal to 0. Now we are getting the value of Z22. So V2 is equal to Vs. I1 is equal to 0. So Vs Vs is equal to 1 and V2 is equal to, from these equations, this is Vs is equal to Z22 I2. So again, Vs by I2 is equal to when I1 is equal to 0 is equal to Z22, where I2 is equal to 0. So Vs by I1 is equal to Vs by I2, which leads to the condition of symmetry, that is Z11 is equal to Z22. So condition of symmetry is equal to Z11 is equal to Z22. So in open circuit impedance parameter, so derive the open circuit parameter and find out the condition of reciprocity and symmetry. It's a full 8-mark questions.